Hello students, welcome to Board Maths Made Easy. In today's class, we are going to do exercise 1.2 problems step by step and be clear on the concepts. Also, there will be very less number of models, and if you understand each and every problem, how I'm going to resolve, you can follow the exact same steps so that a minimum of 2 or 3 marks will be kind of question will be guaranteed in this particular exercise. Here, the first question in exercise 1.2 is prove that square root of 5 is irrational. And you can prove irrationality in two methods. One is proof of contradiction. That means you assume that the given number is rational and you fail finally in proving your assumption. Okay. So that method how we do, that is proof of contradiction, we will see. And also the second method is applying the rules like rational plus rational number is rational, but irrational plus irrational or irrational minus irrational is always irrational. Similarly, rational into irrational or irrational into irrational always gives irrational number only. So these are the two rules we will use in this particular exercise. So when to use what? Generally, if a number is like if you look at this first question, prove that square root of 5 is irrational. Here the number is single irrational number. So in this case, you better to use always contradictory method. Okay. So first what I am going to do is I am going to assume they are saying prove it as irrational, but I am assuming that let us assume that square root of 5 is rational. We are not saying it as irrational. We are saying no, it is rational. If we fail to prove it, then we will come to like okay, our assumption is wrong. That is the contradictory method. Now, any rational number, if you recall, we can write in the format P by Q. Correct? So, if I square on both the sides, what will happen? 5 is equal to, I am doing square on both the sides, then 5 will become P square by Q square. Correct? So, what does it mean? See, you can write it in the below because I am trying to ensure that the video is not scrolling over pretty frequently. I am trying to optimize here, but you can write in the below each line, okay? Because that is much better for your notes or exam point of view. So here, p square is equal to 5q square. That means what we can say, q square is equal to p by 5. Correct? We can write this as q square is equal to p square by 5. And this is some number whose square is divisible by a prime number called 5. Then p is, if you recall that rule, if square of a number is divisible by a prime number, then it's a square, the number itself. Like say, square of a number means p square. And the number means p. So p is also divisible by q. And very important thing here, whenever you are assuming root 5 is equal to p by q, p and q are always co-prime. Okay, so and here when you are writing that line also you better to write here. So therefore root 5 is equal to p by q, where p and q are co-prime, where p and q are co-prime. Okay, so I'm trying to move little this side, are co-prime. Co-prime means they do not have any common factor other than 1. Correct? So that means if p and q, if there is no common factor, then they are co-prime. But if we are going to get in the later steps, p and q have some kind of common factor, then that assumption that okay, we can write root 5 as p by q is invalid. Okay, now coming back to what we have done, we took the root 5 is equal to p by q, We have done the square on the both the sides, and 5 is equal to p square by q square. Therefore, p square is equal to 5q square, and q square is equal to p square by 5. Here, don't look at this one. Here, p square is divisible by 5 is important. If p square is divisible by 5, p is also divisible by q by 5. Okay, so this is important. And similarly, so let us say p is factor of some 5. That means p is equal to 5 into some constant k. 5 into k. So we know that here from this particular formula, p square is equal to 5q square. So in place of p, if I substitute this particular value, that means 5k whole square is equal to 5q square. What does it mean? It means 25k square is equal to 5 times q square. Correct? So here, what we can say here, if you truncate both the sides, the 5k square is equal to q square. So that implies q square is equal to, not q square, k square is, that implies k square is equal to q square by 5. If here earlier we have got p square is divisible by 5. Okay, here p square is divisible by 5. Here what we got, q square is divisible by 5. That means if q square is divisible by 5, q is also divisible by 5. But if you recall, p and q are co-prime. P and q are co-prime. What does it mean? It means they do not have anything which is common, which can exist in both p and q. But here you are saying p is divisible by 5, q is divisible by 5. That means they have a factor called 5 times something and 5 times something. P is some p already we got like 5 times k, and q is something like 5 times something else. So that means both have got 5 as a factor, which is contradictory because they are co-prime. So the assumption that root 5 is rational and it satisfies p by q kind of format is wrong. That this assumption, okay. Therefore, the assumption root 5 square root of 5 is rational and it satisfies p by q is incorrect. What does it mean? It means our assumption is wrong. Therefore, root 5 cannot be a rational number. Since our assumption, since p and q are, you can write like that, since p and q are co-prime, but by assuming root 5 is equal to p by q is rational, okay, we got p and q as not co-prime. This is contradicting the assumption that p by q, p and q are co-prime. Correct? Therefore, that means, or simply therefore, our assumption of root 5 is rational is incorrect. So this is the exact methodology, and step by step you need to prove all the root 2, root 3, root 5 in the same way. So if you know this root 2, root 3, root 5, in other kind of problems, you don't need to prove again root 2, root 3, root 5 are irrational or not. Okay? This particular method we use only when there is a root 2, root 3, root 5, if they are asking to prove whether it is a irrational or rational. So if they are asking to prove it as a irrational, you assume contradictory method, assuming a root 5 or root 2 or root 3 as rational. Try to solve the problem in this exact manner, and okay, then you are able to prove anything. And if it is given as part of a bigger problem, like a prove next question we will see in there. So the next question is prove that 3 plus 2 root 5 is irrational. Okay, so let us assume this is a rational number. Okay, so what I would say, let us assume 3 plus 2 5 root 5 is rational. This is assumption. Let you can write, let us assume 3 plus 2 root 5 is rational, and which is equal to some rational number, say r. Okay, and where r is some rational number. See, we whatever you know in the mathematics, if we don't know that value, we used to assume something as x, etc., etc., right? So for rational numbers you can assume that. Here in this case, see here the case is 3 plus 2 root 5. It is not like a plain root 2 root 3 root 5. In the case of root 2 root 3 root 5, we need to go by the contradiction, and we assume that as a p by q. But in this case 3 plus 2 root 5, we need to assume it as a r. So this is the only trick if you want to assume it as, but I don't want to say something as a trick or tip. Okay, the thing is here, if already it is a given as a some rational plus some irrational number like this, if they are given, assume it as a r. So you know it 2 root 5 is equal to r minus 3. So r is a rational number. We know that 3 is also a rational number only. Why? Because you can write it in the p by q format. Like a 3 is can be written as 6 by 2. This is very easy, right? So both are rational. Yeah, right. We have one rule. There are certain rules we should understand. That is called closure properties. Irrational closure properties. I am trying to write here the closure properties. Irrational minus rational is rational only. Rational minus rational is rational. Or if you say rational plus rational also, here I would say rational plus or minus rational is equal to always a rational number. Similarly, here r is rational, 3 is rational, therefore 2 root 5 is rational by this particular rule. Therefore, with this closure property, 2 root 5 is equal to rational minus rational, therefore 2 root 5 is rational. Am I correct? So 2 root 5 is equal to r minus 3 is rational. Root 5 is equal to r minus 3 by 2. This is also rational. Why? Because anything you can write a rational divided by some other rational number, it will always give you in the rational number. That means root 5 is, that means, therefore I can say that means, okay, I am writing in the next line, that means root 5 is rational. But from the previous example, okay, here as we are doing only a specific problem, we are trying to immediately refer the previous problem and say that okay, we have previously proved that root 5 is irrational. But what will be the scenario in your program? You are not proving first root 5 as a rational or irrational something, right? Okay, but do you need to again prove root 5 is rational or irrational? No need. You can say that we know in the example you don't need to prove again. But we know that root 5 is irrational. We know this already. But what we have proved after so much of exercise, we proved that root 5 is rational. So why we try to prove root 5 is rational? By assuming root 5, 3 plus 2 root 5 is rational, and we got this, but we know root 5 is irrational. So the true fact is root 5 is the rational, but by our assumption, let 3 plus 2 root 5 is rational, we prove root 5 is irrational. As we are assuming that and we are proving that as a rational. Okay, so it contradicts. It doesn't follow the rules. This is therefore 3 plus 2 root 5 is our assumption as rational is incorrect. Therefore 3 plus 2 root 5 cannot be rational. Cannot be rational. Our assumption is wrong. Am I correct? So our assumption that 3 plus 2 root 5 as a rational number is incorrect. Why? Root 5 is irrational. That is well known thing. Okay. So this is the second method to prove any irrational numbers which are like rational plus irrational content. It will be it can be assumed like a rational number. Try to get the irrational part to the left side, rational part to the right side, and we know this. Here you don't need to again prove root 5 is irrational. We know it already. Okay, so that is the reason we say it as irrational, and our assumption is wrong. Okay, let me move to the question number 3, and it has 3 sub questions. We will look at each and every question of that. So we will try to solve all the 3 problems. Okay, in this particular problem we have 3 different sub problems. I am taking the first one. If 1 by root 2 is let us say 1 by root 2 is a rational number and it is equivalent to some r. Okay, 1 by root 2 is some r. R is a rational. R is rational number. If r is rational number, okay, how can I write this one? Rewrite. If I write root 2 is equal to, that means if I interchange these sides, or if I say 1 by root 2 is equal to 1 by r. I hope you don't need that level of cross. Okay, so what we did 1 by root 2 is equal to 1 by r. Both the sides we have done 1 by. So root 2 is equal to r. So here what you are doing is root 2 is equal to 1 by r. Some 1 is some number divided by, like you are writing like something 1 by an example here, like suppose anything you are writing 1 by 3, 1 by 4 or 1 by 5. That means these are all rational numbers. So here when you are writing root 2 is equal to 1 by r, means you are making root 2 as a rational number. 1 by rational is equal to that m plus root 2 is also a rational number. But we know clearly root 2 is irrational number. Remember, how do we know before this problem? See, if they are asking to prove root 2, root 3, root 5 as a irrational number, then you are going to assume the contradictory method. But already you know there. Okay. See, here the expectation is that when they are asking this kind of questions, you know already root 2, root 3, root 5 as irrational numbers. You don't need to prove them again. Okay. So therefore root 2 is rational, and we know it. We know root 2 is a irrational number. But here we got root 2 as a rational because we written it in the format 1 by r. This contradicts. Okay. This contradicts. This what contradicts? This contradicts our assumption, or our assumption contradicts the root 2 is irrational. Therefore already the proven things are correct, but what our assumption is wrong. Therefore our assumption that 1 by root 2 is rational is wrong. Therefore our assumption that 1 by root 2 is rational is wrong or incorrect. What does it mean? If this is incorrect, the opposite is correct, right? That means, okay, that means, or therefore 1 by root 2 is irrational. This is called as a proof of contradiction. This is the only chapter having this kind of methodologies. Okay, so rest of the chapters will be much more clean and easy to understand. Okay, so don't worry. The next problem is proving the 7 root 5. Okay, so let me put the 7 root 5 as the next question to be solved. Okay, there is one more closure property. If I want to say, it is rational into rational gives rational number. Rational into rational gives rational number. What does it mean? Suppose you say 3 by 7 into 2 by 9. Both are rational numbers. What is the rule for rational numbers? You should write it in a p by q format. That's it. Nothing much. So here 3 by 7 into 2 by 9. What will happen? This is example. Okay, don't get confused with this. Here I am saying the property. So 3 by 7 into 2 by 9, 3 times cancels. That gives us a 2 by 21. So this is another rational number. Just to prove that is this a right thing or wrong thing, that property, we can prove it. But we don't require to prove anything, because the problem they asked is 7 root 5. So here 7 is rational and root 5 is irrational. And there is another property, rational into irrational is always irrational. A multiplication of rational into irrational is irrational. Here, in this case, 7 root 5, rational part is what? 7. 7 can be written as 21 by 3. You can write any number of times, any types of P by Q formats. So, but P and Q should be co-prime, right? So if P and Q are co-prime, rational, this can be represented as a like a P by Q format. Okay, and because if you write it, you will write it only 7 by 1. That's it. And irrational numbers, you cannot even write it in the P by Q format. 7 into root 5. Yeah, 7 is a rational, root 5 is a irrational. So what it should give, as per this particular property, it should give a irrational. So 7 root 5 is irrational or rational? Root 5 is always irrational, even if you go through the other method. Okay, so if you assume by this is using the property. If you want to go for the contradictory method, same thing, you can write 7 root 5 is equal to r, root 5 is equal to r by 7. Okay, r by 7, this is a rational number, r 7 is a rational number. So rational by rational, what is the thing? Rational by rational is always rational, we know that. Rational by rational is equal to rational. So what you are saying by this kind of, see, this methodology up to here is assuming using the property. This method here you are using contradictory method. Let us say 7 root 5 is rational, then root 5 is equal to r by 7. Therefore, here r is rational, 7 is rational. Rational by rational always gives a rational, that is the property. Therefore, whatever is there, r by 7 is equal to root 5. So by 7 is equal to root 5. Root 5 is rational. That means root 5 is rational. This is another method, the above part. This is one method. This is the second method you are doing, remember. And in the exam, most probably, if they are asking using the properties they are asking, then you can do this. If not, you can do this. If they didn't say, you can use any one, whatever is you are more comfortable. Okay, no wrong. But if they ask you by using the proof of contradiction, then you need to use explicitly this method. So root 5 is rational, but we know it. Root 5 is, but we know root 5 is rational. So our assumption that 7 root 5 is rational is incorrect. That means our assumption is incorrect. That means 7 root 5 is rational is that means 7 root 5 is rational, as our assumption is incorrect. See, language you can write in any way as long as you are making the same meaning. Okay, incorrect. That's it. Okay, next problem. Okay, so 6 plus root 2. 6 is what? 6 is the rational. Root 2, we know it clearly. Root 2 is irrational. And if you recall the properties, rational plus irrational, rational plus irrational always irrational is always gives irrational only. So here 6 is rational and root 2 is irrational. 6 plus root 2 always gives same is a 6 plus root 2 is irrational. There is no ambiguity in this. In case if you want to prove it by the contradictory method, we have already seen the first problem, right? So we can go there and compare like this one. Like if you recall this one, prove that 3 plus 2 root 5 is irrational. This is a, we can say this closure properties, rational plus or minus rational. Or if you take also 3 like 6 plus root 2 is rational, assume it as r, so root 2 is equal to r minus 6, and r minus 6 is irrational minus rational is always rational. That's why I mentioned clearly closure properties. You should be very clear of these particular properties. Closure properties, rational plus or minus rational is equal to rational. Similarly, rational into irrational is always irrational. Okay, similarly, and see, irrational by irrational, suppose both have the root to root, it will get cancelled. Okay, that is true, but it depends on certain scenarios only. But naturally, irrational plus irrational is always plus or minus is always irrational. Similarly, irrational into irrational is always irrational. Okay, and irrational plus or minus rational plus or minus. Remember, rational plus or minus rational is always rational. Irrational plus or minus irrational is always rational irrational. Similarly, rational plus or minus irrational is always irrational. Okay, so I will put it in a simple format. Okay, look at this box where I have mentioned all the properties. If you remember these properties, you can prove any irrationality. Rational plus or minus rational is equal to rational. Irrational plus or minus irrational is equal to irrational. Rational plus or minus irrational is equal to, see here, rational and irrational lead to irrational. Rational plus or minus irrational. Rational into irrational, irrational. Irrational divided by irrational is equal to irrational. If you remember these properties, you can solve any problem. Okay, with that we conclude the chapter 1, real numbers. So in the next video we will start with the polynomials and we'll continue. Thank you.